All right, good morning and welcome to mathsatoka online class. In today's video, we'll be solving calculation on fundamental physics. Okay, this is general physics for 100 level students. Okay, yes, for every 100 level students first semester. So we'll be solving calculations on that. The first topic, which is our chapter 1, is unit and dimension. So we'll be solving calculations on unit and dimension. So please, if today is your first day of watching our video, please like this video, comment as well, then join the family by clicking that red subscribe button so that anytime we drop a video like this, YouTube will notify you. Don't forget that this channel is strictly for calculations on maths, physics and chemistry. So if you have any maths problem, you can drop it for us, we'll tackle it. So the first question here said we should find the unit and dimension of velocity. Don't forget that velocity is meter per second, okay? Or you can write it like this, meter per second. That is displacement over time. Now, in dimension, the three main quantities we use for dimensional analysis is what? Is mass that is measured in kg, and the dimension is m. Then the next one is length. Length is measured in meter, the dimension is L. Then finally time is measured in second, and the dimension is t. So I have meter. What gave us meter is L, so dimension L, and then what gave us seconds is time. So this is the dimension for this. So the next one we're looking at is force. Don't forget that formula for force is what? Mass times acceleration. Mass times acceleration. Don't forget that the unit is measured in Newton. Okay, then another unit for it is what? Don't forget that mass is kg, then times acceleration is what? Meter per second square. Okay, meter per second square. So force is measured in what? In kilogram meter per second square. Okay, and kilogram is what? Is mass. Then m is what? Your length. Then per second square. Okay, so that is the dimension for force. It's very, very simple. So we move to the next one. Question number 3. Question number 3 said walk. The dimension for walk. Now walk is what? Force times distance. Okay, force times distance. And the force, don't forget we have gotten force to be what? Kg meter per second. Okay, times distance is measured in meters. Okay, so m and m will give you 2m. So I'm going to see that what? Walk is normally measured in joule. That is the SI unit. But it can equally be measured in what? In kilogram meter square per second square. Because I have meter. Okay, so kilogram is giving me m as mass. Then meter is giving me length with square there. Then seconds is giving me time. So this is the SI unit for work. Okay, now energy and work are the same thing. Energy is equally measured in joule, or you can measure it in what? Kilogram meter square per second square, which is what? ml2 t minus 2. Right, so the next one is tension. Tension and force are the same thing. So tension is the same thing as force. So I'm having Newton here, or kg meter per second square, which is what? mlt minus 2. So the next one is acceleration. I told that acceleration is measured in what? In meter per second square. So which is what? Meter is L, per second square is what? Time minus 2. So the next one is what? Linear momentum. Now you should know that momentum is the same thing as impulse. Okay, and impulse is what? Force times force times time. Yeah, that is impulse. Force times time is impulse. Okay, so momentum is equally mass times velocity. So let's check if both of them will give me the same thing. Now I have that force is m. Okay, we have gotten force. Where is our force? Force is what? Kilogram meter per second square, then times another seconds, which will give you kg m s. 2 minus 1 will give you minus 1. Okay, so this is that. Now let's check here if it's the same thing. Mass is kg, then velocity is measured in meter per second. Per second. So if you look at, they are the same thing. So the SI unit for linear momentum is what? Newton seconds. That is force times time, Newton seconds. Or you say that it is what? Kg meter per second. So which is what? My kg is what? Is mass, gave us kg. My meter is what? Length. Then what? T is what? Minus 1. So that is that. So the next one you look at is torque. Torque is the force times the perpendicular distance. Okay, force times perpendicular distance. So force times distance is what? Is your torque. So torque is the same thing as work. Work and torque are the same unit and the same dimension. Okay, so work and torque are the same thing. So measured in joule, okay, or you say kg meter square per second square. Okay, which will give you what? ML2 T minus 2. All right. So the next one is angle. Angle is dimensionless. Angle is what? Dimensionless. There is no dimension for angle. So we move to the next one. The next one is what? Density. Don't forget that density is measured in what? Density is mass over volume. Density is equal to what? Mass over what? Volume. And mass is measured in kg, while volume is measured in what? In meter cube. Because of the over, I'm going to put per meter cube. So the SI unit, so this one is the unit here is degree. It's measured in degree, but it is what? Dimensionless. Okay, so density is what? In kg, kilogram per meter cube, and kg gave us mass, then meter gave us L, then minus 3. So the next one we are looking at is what? Pressure. Now pressure is what? Force over what? Over area. So what is our force? Don't forget that we have gotten our force. Force is measured in Newton. Then area is meter square. So I have Newton per meter square. So the SI unit for pressure is what? Newton per meter square. Or it can equally be measured in. Don't forget that force gave us where is our force? Force gave us kg ms minus 2. Now divided by another mo2. So this one cancel one of these. So I'm having that it is what? Kg mo minus 1 s minus 2. So I have that it can equally be measured in kg mo minus 1 s minus 2. So if you now convert it, kg gave us m, m gave us L, you put the minus 1, then seconds gave us time, you put the minus 2. So the next one is what? Action. The dimension of action. Action means energy times time. Okay, the energy you put in a particular time is called action. So action is what? The energy we put in energy we put in a particular time. So energy times time, and energy is measured in joules times what? Time. So which is what? Joule second. Joule seconds is what? Is your action. But it can equally be measured. Don't forget that our joule is energy, which gave us kg mo squared s minus 2. Then times another second. Minus 2 plus 1 will give you minus 1. So I have kg mo2 s minus 1. So if you put it, that is equally what? Kg mo2 s minus 1. So if you now put it here, you have that what? M, capital letter M. Then I'm having a L2, then T minus 1. Then finally, the last one is what? Power. Power is what? Work done over time. Okay, or energy over time. Power is work done over time or energy over time. So power is equal to what? The work done over what? Over time. So that is why we have that is what? Joule per second. Because work done is joule. So power is what? Joule per second. Or what? Or watt. Another SI unit for it. In fact, the SI unit is watt. It is equally measured in what? In watt. Or you can measure it in what? Joule gave us kg m squared s minus 2. Then times another s minus 1, which will give you kg mo2 s what? S minus 3. All right. So you now put it here that it is equally measured in is equally measured in what? Kg m squared s minus 3. So which is what? My kg is m, my m is L2, then T minus 3. So that is the unit of power. And I don't think we have another one. So thank you very much for watching. So please, let's continue. The next question we're going to solve here said we should distinguish between fundamental quantities and derived quantities. Permit me to clean everywhere. Okay, they say distinguish between fundamental quantities and derived quantities. Then list 3 fundamental quantities and 6 derived quantities. Okay, you can do that for me at the comment section. I want to see that. Tell me the difference between fundamental quantities and derived quantities. Then you now list the fundamental quantities for me, okay, and then the derived quantities. Don't forget that we are here for calculation. So question number three said the velocity v of wave setup in a stretched string, comma, by plucking it, comma, can be given in terms of tension F in the string, comma, length L of the string, and the mass M in the string, as V is equal to K F X L Y M what? M Z. Okay? The question now said M Z. The question now said where S, comma, Y and Z, where are numbers, and K is the constant of proportionality. Then I say use dimensional analysis. To calculate S, comma, Y, comma, Z, and hence prove that V is equal to K in bracket of F L slash M. Okay? All raised to power 1/2. And then I say is equal to K, the square root of tension over mass per unit length. Okay? Mass per unit length. Okay. Now, if you look at this question, it seems it's very long, but it's a very simple question. So what are we expected to do? They've given us that solution. They've given us that that our V is equal to K F X L Y and M Z. All right. Now let us put everybody in the normal dimension we know. The three quantities we use for dimension is what? Mass, length, and time. So we know that velocity, they told us that V is velocity, and velocity is measured in meter per second, and the dimension is what? LT minus 2. Sorry, minus 1. Okay, meter per second is equal to, forget about K. They say that K is proportionality constant, but we know the next thing we should know is that what? Force. What's the dimension for force? The dimension for force gave us, from what we did before, the dimension for force gave us M L T minus 1 minus 2. That is mass times acceleration. Okay, don't forget that it all has raised to power x times our L is normal thing, L raised to power y, and then our mass is normal, M raised to power z. Okay, so now we now have that. Let the left hand side equally have M. So since there is no M here, you put it as M raised to power 0, because anything raised to power 0 is 1. Then I have L raised to power 1. N raised to power 1 is the same thing. Then T raised to power minus 1 is equal to, share it for them, M raised to power x, L raised to power x, then T raised to power minus 2x. Then I have L raised to power y, and then M raised to power z. Now this is what? M raised to power 0, L raised to power 1, T raised to power minus 1 is equal to, according to indices, if the base are the same thing, we should add the power. So I have that M raised to power x plus z. Okay, then L raised to power x plus y. Then finally T raised to power minus 2x. Now by comparison, we'll see that what m and m, so I have that what m raised power 0 should be equal to m raised power x plus z, which shows that what if this take care of this, we see that what x plus z is equal to 0. We can call it equation 1. Okay, now if you see that l raised power 1 should be equal to what l raised power x plus y. So if this take care of this, we'll see that what that x plus y is equal to what 1, equation 2. Then finally we can see that what t raised power minus 1 is equal to what t raised power minus 2x. Okay, so if this take care of this, we'll see that what that minus 2x is equal to what minus 1. So you will now see that x will now be equal to what minus 1 divided by minus 2, which is 1 over 2. So if x is equal to 1 over 2, to get my y is very simple. I can put it here to see that 1 over 2 plus y is equal to 1. So therefore my y will now be what 1 minus half, and 1 minus half is still what is still half. Okay, so my x is equal to my y. So putting it in equation 1, I know that my equation 1 is what is x plus z is equal to what 0. So therefore half plus z is equal to 0. So z is equal to what minus half. So I've gotten my x, y, z. That's the first calculation. So the second one they say we should get is that we should prove that z is equal to this. So if you now that v is equal to this, permit me to clean here. So if we now put the value of this, you now have that v is equal to from what we have here, from this dimension we have here, we have that v is equal to what k f raised to power, what is my x? My x is 1 over 2. Then my l, my y is equal to 1 over 2, and then my m z is equal to minus 1 over 2. And according to indices, if you want to bring the minus down, if you want to remove the minus, you do the reciprocal of this man. So this is written as what k f raised power minus 1 over 2, l raised power minus 1 over 2, all over m raised power 1 over 2, to remove the minus. Now this is now k in bracket of, they all have 1 over 2 in common, so I can say fl over what m, everybody raised power what 1 over 2. So I have proved the second one. Then the next one which we are asked to prove is that that v is equal to, now if you look at it, this is k the square root of, because raised power 1 over 2 means square root, the square root of what force times length, length over what over mass. Now but they want the length and mass to be at the denominator. So if you want this thing to be at the denominator, that is, you want it to be divided. So if you change times to divide, these people will turn upside down. Okay, this is what they want us to get, that is tension over mass per unit length. So if we do that, you are going to see over means divide. So my v will now be k the square root of what force divided by, if you change divide to times, these people will turn upside down, that is mass over what over length. So and divide is the same thing as what as square root. So this thing is now what k the square root of force is the same thing as tension. So we use tension, they use tension in their own. So let me change it to tension. So we now have what tension, divide means over, over mass per unit. Per unit means this divide they are seeing here. So per unit length. So it is proved. All right. So we'll go to the next question. I hope you understood this. So the next question here, question number 4. Question number 4 said, question number 4 said the force F between the sun of mass m and the earth of mass capital letter M separated by a distance r is given as F is equal to m m, F is equal to 1 over r squared, where g is the universal gravitational constant. Okay, then I say use dimensional analysis to obtain the unit of g. Okay, we want to use dimensional analysis to obtain the unit of g. Now we equally use it to obtain the dimension of g as well. Okay, so let me even put it the unit and dimension of g. Okay, solution. They have given us the formula, thank God. They say that F is equal to g m over what? R squared. Now don't forget that force is the same thing as mass times what? Acceleration due to gravity is equal to what? G m over what? R squared. Now one of these m can cancel one of this m. Okay, so I am left with what? I am left with that g is equal to what? Gm over what? R squared. Whether the m is capital letter or small letter, it does not matter. In dimension, it does not matter. So now, if we make this g subject of formula, that's what we are looking for. We see that g is equal to what? Cross multiply this time this to have that what? G r squared, then divided by my m. Okay, now this one now, watch, this one now is g is what? Acceleration due to gravity, measure the meter per second square. Now r is distance, and distance is measured in meter square, over my m here is mass, and mass is measured in kg. Okay, so now this and this will make it 3. So I have that what? Kg, because it is down, if it's coming up, it's going to be -1. Then I have my m in that is 3, then my second that is -2. All right, now if you, this is the unit. If you want to use dimensional analysis to get the unit, now to get the dimension, kg is what? Capital letter M, you put the -1. Meter is what? Capital letter L, put your 3. Then s is your time, you put your -2. So this is the dimension of g. All right, but normally the unit of g here is from here. If you cross multiply here, you have that g is equal to what? F r squared over m squared. There's m here, m squared, which is what? This is Newton kg per 2, then what? M squared. So that is the unit of g here. But this one works as well. Okay, they are all the same thing. So move to question number 5. So question number 5 said a simple pendulum. Question number 5. A simple pendulum made up of a small mass m suspended from a long thread of length L is set into oscillation from a long is set into oscillation, full stop. Then I said if the period t of the oscillation is related to m, l, and the acceleration due to gravity g by the equation. They are related by the equation t is equal to k m raised to power x, l raised to power y, and g raised to power z. Okay, then I say where your x comma y comma z and k are dimensionless, dimensionless constants. Then I say dimensional dimensional analysis to obtain values of the constants x comma y comma z, and hence an explicit expression for t. Okay, this is a very simple question. So what do? They have given us the formula to use. They say that our t, which is time, okay, period, is equal to k m l and g z. Now, normally, let's put everybody in the normal three quantities for dimensional analysis. So our t, this is t raised to power 1, okay, is equal to what? K m raised to power x, l raised to power y. Don't forget that our g is measured in meter per second square, and meter is giving us what? L per second square is t minus 2. Don't forget that they are all raised to power what? Z. So let me share it for them. As I'm sharing it for them, I have that t raised to power 1 is equal to what? K m raised to power x, l raised to power y, l raised to power z, and then t raised to power minus 2z. Okay, now I need everybody to be, even the left hand side, to have the same dimension with the right hand side. So forget your k. Your k is a constant. We don't need the proportionality constant. Okay, so this will now be what? M. There is no m here, so it will be m raised to power 0. There is no l raised to power 0, but there is t raised to power 1 is equal to m raised to power x. According to indices l and l, so I have l raised to power what? Y plus z. Then finally t raised to power what? Minus 2z. Now, if you compare the left hand side and the right hand side, you'll be having that m raised to power x is equal to what? M raised to power 0, to show that what? Our x is equal to 0, comma. Then the next thing we will see that what? L raised to power 0 is equal to what? T raised to power y plus z, which will show us that what? That y plus z is equal to 0. Then finally, we'll see that t raised to power 1, is equal to t raised to power minus 2z. So if this take care of this, you see that minus 2z is equal to 1. So z will now be minus 1 over 2. So if you put z to be minus 1 over 2, you have that what? Y is equal to, y plus minus 1 over 2 is equal to 0. So therefore, y will now be 1 over 2. So if you have gotten that, now let's get the expression. The expression will now be t is equal to what? K. Now x is raised to power 0. So you have what? M raised to power 0. Then L is going to be raised to power my y, which is 1 over 2. And then my g will now be raised to power what? Minus 1 over 2. Okay. Now if you want m raised to power 0 is 1, so it's gone. If you want to remove the minus, it will come down. So let me write it here. So I'll have that what? T will now be what? K L raised to power 1 over 2 over g raised to power what? 1 over 2. Now don't forget that 1 over 2 means square root. So finally this is what? K, the square root of L over what? Over g. Because both of them are all made up of 1 over 2. In fact, it's supposed to be K in bracket of L over g. Everybody raised power half. And everybody raised power half means that everybody will be covered with the square root. So I am done with that question number 5. So question number 6. Question number 6. So question number 6 said, give the relationship, give the relation, okay, the relation between, give the relation between the first question, a square inch and a square meter, okay, a square centimeter. B question said a square a square mile and a square kilometer. C question said a cube a cubic meter and a cubic centimeter. Okay, so these are the three questions we want to look at. Now the first question said we should look at a square mile and what that is question number 6. Now you should know that 1 inch 1 inch is equal to what? 2.54 cm. You need to know this. Okay, and a square inch means to square both sides. To square both sides, have 1 inch all squared will now be what? 2.54 cm all squared. So 1 squared is 1. So 1 squared inch squared will now be what? 2 point this squared will give you 6.45 cm squared. So a square inch, that is A means 1. That is 1 square inch is equal to what? 6.45 cm squared. That is centimeter square. That is that. We move to question number B. Just once you know the relationship between them, you are good to go. So first of all, you need to know that 1 mile, because they say a go for mile. So that's why we are having 1 mile. 1 mile is equal to 1.6093 kg, kilometer. Sorry, kilometer. Right. So 1 mile all squared will now be 1.6093 km, then all squared. So 1 squared is 1. So I have 1 mile squared will now be what? This squared will give you 2.589, then kilometer squared. So that is that. So we'll move to the next one. The only problem is to know their relationship. So you have to know their relationship. Once you know their relationship, you are good to go. So the next one, the C part of it said a cube meter. So 1 meter is equal to I think 100 cm will give you 1 meter. So it's equal to 100 centimeter. Okay, let me say 1 meter like this is equal to 100 centimeter. So if you square it, 1 meter, okay, cube, if you cube it, 1 meter cube is equal to what? 100 cm cube. So 1 cube is still 1. So I have 1 meter cube is equal to what? 100 raised to power 3 will give you 10 raised to power 6 cm cube. So 1 meter cube will give you 10 raised to power 6 cm cube. So we'll move to the next question. Question number 7. I hope this is not difficult. The only problem you need to know is their relationship. So the next question, question number 7. Question number 7 said, show that 1 watt is equal to what? 10 raised to power 7 ERG per second. Okay. Now, to do this, first of all, solution. We know that power is equal to what? Energy over time. Okay, power is equal to energy over time, and energy and work is the same thing. So if you convert it to work, you see that this is something as what? Work done over what? Over time. But don't forget that work done is what? Force times what? Distance, then over what? Over time. So once you have this, then the next thing you need to know is that force means mass times acceleration. So let's break everybody down. Force is what? Mass times acceleration times the distance or displacement. Anyone, distance is okay. Distance over what? Over time, because work is a scalar quantity. So that's why we are using distance. Okay, so once you know this, then the next thing you need to know is to convert everybody in its unit. To convert everybody to unit. So the unit of this is what? Kg times acceleration is what? meter per second square times distance is meter all over what? Then your time is seconds. Okay. Now, the only thing is that the only problem here is that to convert to ERG now, we need, this one is in seconds, no problem. To convert to ERG now, the only problem we have, okay, let me leave it as X, as S. So the only problem we have in converting this to seconds is so the only problem we have that ERG is made up of gram and centimeter and not kilogram. Okay, gram and centimeter. So once we have that now, what do we do? So let's convert to gram and centimeter. So now converting kilogram to gram is 1000. So this thing means 1000 gram times now centimeter, from meter to centimeter is 100. 100 centimeter will give you 1 meter. So I have 100 cm per second square. Then times, convert this one again, 100 cm again, 100 cm, then all over your second. So if you multiply everybody now, you are going to have that this is equal to how many zeros? 1 2 3 4 5 6 7. So I have 10 raised to power 7. What I have here is what? G, okay, cm. Cm and cm will give you cm square. Then I have what? S raised to power minus 2. Don't forget over second. Why am I leaving this over second? Because of the per second that I'm having here. So now if you have that, you're going to see that this thing is the same thing as what? Let me write it as, okay, now you should know that GCM square, just know that 1G cm square S minus 2, one of these is equal to what? 1 ERG. You should know this, please. So therefore 10 raised to power 7 GCM cm squared S minus 2 is something as what? 10 raised to power 7 ERG. So if you now put it here, you are going to see that this means 10 raised to power 7 ERG per second. So it is proved. Okay, the per is because of this divide, then over second. So that is that. We move to the next question, which is question number 8. Let me check my video if it's still moving. Okay, still moving. So the next one, question number 8. Question number 8 said, is it necessary to specify the temperature of which a standard meter is made? Then why? Do you consider temperature a fundamental quantities? So answer that in the comment section. The first question said, is it necessary to specify the temperature of which a standard meter is made up of? Is it necessary? Then tell us why it's necessary. Then the next thing you should tell us is that what? Do you consider temperature as a fundamental quantity? Okay. So question number 9. Question number 9 said, list any 10 phenomenon each of which to repeat itself regularly that it can be used as a reasonable time standard. We are here for calculation. So question number 10 said, show that 1 watt is equal to 10 raised to power 7 ERG per second. Well, we will just prove that now. So the final question, which is question number 11. Question number 11 here said, convert a density. The first one said convert a density of 0.0045 kilogram per cm cube to the SI unit. Okay. Then question number 2 said density of 10 gram per cm cube to the SI unit. Okay. That's the last question we're going to solve for this chapter. So now, to convert this density, what do we do? Density conversion. Okay. Solution. We have that First of all, we have that the first one gave us 0.0045 kilogram then per cm cube. All right. Now is equal to, my kilogram is normal, so 0.0045 kilogram is normal. The only problem here is what? Converting centimeter to meter. So how many centimeter will give you 1 meter? 100 centimeter will give you 1 meter. But don't forget that when you are converting from the small person to the big person, we are dividing. Okay, you know that 100 centimeter is giving us 1 meter. Okay, so now 1 centimeter will give us x meter. If you cross multiply, you find out that you are dividing. That is 1 divided by 100, which is 0.01. So 0.01 centimeter will give us what am I saying? 1 meter. Sorry, 1 centimeter will give us 0.01 meters. Okay, so we are dividing by 100. Just know that if you are just know their relationship, then know if you are moving from the big man or the small man. The relationship between centimeter and meter is just 100, but we don't know if you are multiplying or dividing. Okay, so since we are converting one, there's invisible one here, 1 centimeter, we are moving it to meter. It will be that one. Since you are moving from centimeter, the small man, to meter, we divide it by 100. But at DB, we are moving 1 meter now to centimeter. So 1, you write the 1. Moving from the big man to the small man, you multiply by that, their relationship. Have you seen how to convert? So it's very, very simple. So it's going to be what? 1 divided by 100 will give you 0.01. Because of the cube, you put the cube, you put the meter, then put the what? Sorry, you put the cube. You are not putting the pi again because it is down. So this will give you 0.004 kilogram all over 0.01 divided by that. 1 divided by 100. 0. Then raised to power 3. So I'm having, that is 1 times 10 raised to power minus 6 in meter cube. So if you now divide this, so 0.004 divided by that, my answer. So it's going to give me 4,000 kilogram per meter cube. Okay, kilogram, not kilometer. So 4,000 kilogram per meter cube is the answer to that. Okay, there is 5 here. So 4,500. So 4,500 kilogram per meter cube. Okay, so that is that. We move to the next question. That is II. Now look at II. II said 10 gram per cm cube. Now, which is what? 10 gram over what? Cm cube. Now, converting 10 gram to kilogram, the relationship between gram and kilogram is what? Is 1,000. Is it not true? Now, and we are now moving from small person to big person. I have 10 divided by that 1,000. I'm dividing because I'm moving from the small man to the big man. So 10 divided by 1,000 will give you 10 divided by 1,000 will give you 0.01. So I have 0.01 kg over. We did the same thing here, and he gave us that is 1 divided by 100, then raised to power 3. That is 0.01 again, raised to power that 3. Sorry, put the meter, then raised to power 3. Okay, which will give you that is 0.01 divided by my answer. I have 10,000 kilogram per meter cube. Okay, so that is that. So thank you very much for watching. Please like this video and comment. The more you like and comment, the more YouTube spread it out. Please help us. Like it, comment. I know you like the video, so just click that like button, then comment. Answer those questions I asked you. So bye bye. See you in the next video. Chapter 2.